In this video, I will go over the homework that follows the lecture 19.1 that covers the first order linear differential equations. And as always, I hope that you watched these two lectures, and the homework will have therefore two parts. So let's go ahead and jump right into the first one. And here we have to determine whether a given differential equation is linear or not, and only those differential equations are called linear that have y prime plus, well, here we can have some function in front plus some function of x times y, and all that set equal to some function of x. So only those equations that can be written in this form are considered to be linear, and in this case we see that if you have something times y prime plus something times y squared, so this is what makes it a non-linear differential equation, so the answer is no. We're going to rewrite this in standard form, and to write in standard form means to write it like this. So we have y prime plus some function of x times y, all that is equal to some function of x. So in other words, we're getting rid of the leading coefficient, and in this case here's how we're going to get rid of the leading coefficient. We're going to simply divide everything by the leading coefficient, so assuming that it is not equal to 0. And then we get the desired form. So we might have to simplify it a little bit. And now this is what we would call P, and this is what we will refer to as Q. So let's enter the answer. And I need to report this little glitch with the code. And let's continue. So building off of the previous exercise, the coefficient in front of the function itself is called p, or usually is labeled as p, and the coefficient, the free coefficient, is what we refer to as q. So in our case it should be pretty easy to make that side-by-side comparison and identify this as p and this as q. Now we're going again on the second lap over here. So we have ln of x cubed y prime plus something something of y is equal to something something. So so in our case we do have that pattern, so we do have a linear equation, so I can write those values here. Oh, actually, no, never mind. Oh, good thing I actually decided to write it out, because since we have y over here, that kind of breaks this pattern of only having one y outside of that coefficient. So this is, again, this is a non-linear differential equation. It is still the first order, but it's not linear. We're going to take this and divide everything by the leading coefficient. In this case, I do call it coefficient, but it's really not just a constant coefficient, it's like a functional coefficient. And we also have to assume that whatever we divide by is not equal to 0. So as a result, we get y prime plus 2 tangent x times y is equal to 2 tangent x. So this is what we will refer to as p, and this is what we will refer to as q. So this is 2 tangent x, and this is also 2 tangent x. What a coincidence. Similar problem, and we'll do exactly the same thing. We'll divide everything by ln x, rather 3 ln x, and that means ln x cannot be equal to 0, meaning x cannot be equal to 1, but here's what we get. This is what we call P, this is what we call Q. So Q is 1, P is x over ln of x. Dividing everything by sine of x, and we get y prime. Of course, all of this only makes sense when sine of x is not equal to 0. We have y prime plus 3 cotangent y is equal to 3. Sorry, not 3 cotangent y, 3 cotangent x times y. All right, next question. Number 8. Looks like we have the same question. So we're going to assume that x is not equal to 0, and we'll divide everything by x. So we get y prime plus 2 ln x over x times y is equal to 3 ln x over x. 2 and 3 can be written in the numerator, so here we have 2 ln x over x, and here we have 3 ln x over x. So, next question. Number 9. determine whether the differential equation is linear. And again, in order for it to be linear, we have to have something like this, where a, b, and c are the functions of x only. And here we don't see that. We have this extra y, so no, this is not a linear equation. And here's another one. For the same reason, we're not going to classify this as linear because of this extra y. So the answer is no. And we finished the first objective. So let's go ahead and move on to the next one. Find the general solution to the following equation. So we have y prime plus 4 over x times y is equal to 7x minus 3. And the steps that I'm going to follow are outlined in this video somewhere right over here. So all of these differential equations, and by all of this I mean first order linear differential equations, can be solved in 3 steps. Step 1, we find the integrating factor. Step 2, we rewrite the differential equation using the integrating factor. And then step 3, we find the, I guess there are 4 steps depending on how you look at it, but step 3 and 4, we just solve for y. And the formula for the integrating factor is provided right over here somewhere. It's pretty much right over here. So it's just e raised to the power integral of p with respect to x. So first step, identify p and q, and then find the integrating factor as e to the power integral of p of x dx. So I'm going to integrate p of x, and in this case it will be the integral of 4 over x dx. So it's 4 ln absolute value of x plus c, and we can assume c is equal to 0 here, and the whole thing will be equal to ln of x to the power 4, and absolute value of x raised to the power 4 is just same as x raised to the power 4. And the reason I like it to be written that way is because when you put it back in to the integrating factor formula, we get e to the power ln of x to the 4, and e and ln cancel each other, and we end up with just x to the power 4. Now, why do we choose c to be equal to 0? Because it will work exactly the same way for any value of c, and if it works exactly the same way for any value of c, why work harder and not smarter? So let's just choose c to be equal to 0. In the second step, we're going to use the integrating factor, and we're going to rewrite the left hand side as mu times y derivative, and the right hand side I guess missing the step here of multiplying everything by the integrating factor. Let's see, how did we talk about this? Right, so the right hand side gets multiplied by mu of x, right? So that's the step we're skipping. So on the right side we're going to have q times mu. So in our case, what do we have? We have x to the 4 times y, and derivative of that is equal to 7x minus 3 times x to the power 4. And now we're going to integrate both sides with respect to dx. And on the left side, we're simply going to get x to the 4 times y. Antiderivative of a derivative is the function itself. And on the right side, we just have to do this integral. And it's rather a very simple one. So we have 7x to the power 5 minus 3x to the power 4 dx. So we can continue with this problem. So we have 6x to the power 6 minus 3/5 x to the power 5, and now we can put plus c over here. So finally, to isolate y, we divide everything by x to the 4, and that will be the final answer. So we have 6x squared minus 3/5 x plus c divided by x to the power 4. All right, so this was problem 11. Number 12. So in this problem, we only have to determine the integrating factor. Notice that we don't have to solve it, so let's not go too fast here. First step is to recognize that we have a first order linear differential equation, and we're going to write it in standard form. So we're going to divide everything by 3x squared. So here's what we get. We get y prime. And here, assuming that x is greater than 0, makes the denominator always positive and never equal to 0. So we get 4x times y is equal to 5x squared plus 3. And the integrating factor will be e to the power integral. But before I write that, let us identify P and Q. This is P, this is Q, so it's going to be e to the power integral of P dx, and here I'm going to hit the pause, and I will just find the integral of P dx as the integral of 4x dx, so it's going to be 4 ln absolute value of x plus c. But again, we always choose c to be equal to 0, so after you bring 4 inside, you get the following. So now that we continue the formula for the integrating factor, we get e to the power ln x to the power 4, and after e and ln cancel each other, we only have x to the power 4. So here's the answer. This is my P, this is my Q. We're gonna, step 1, we're gonna find integrating factor as e to the power integral of P dx. Integral of P dx is integral of 4x cubed dx, so it's just x to the 4 plus c, and we can choose c to be equal to 0. Now we multiply everything by x to the 4, so the left hand side becomes the derivative of x to the 4 times y, and the right hand side becomes 20x to the power. I went a little too quick here. We forgot to find the integrating factor. The integrating factor is e to that power. So after you multiply both sides by the integrating factor, the left hand side becomes the derivative of integrating factor times y. The right hand side becomes the q times the integrating factor. And now to undo the derivative on the left hand side, we integrate both sides. So here's what we get. And now to do this integral, we just used all the available tools, one of which is substitution. So we're going to substitute x to the 4 for t, so dt is 4x cubed dx, so dx will be 1 over 4x cubed dt, and continuing with the integral, we have integral of 20x cubed e to the power t, but instead of dx I'm going to write 1 over 4x cubed dt. X cubed cancels, 20 over 4 is 5, so we have 5 e to the t dt, so antiderivative is e to the t, but instead of t I'm going to write x to the 4. So this is the right hand side, and now to isolate y, we're going to divide both sides by the integrating factor, so we end up with 5 plus this will be the general solution. So let's enter this answer. Here we only supposed to find the integrating factor, so let's make sure we don't do anything extra. The integrating factor here is simply e raised to the integral of p dx, which is e to the power integral of 2x squared plus x dx. So it's simply going to be 2/3 x cubed plus 1/2 x squared, and we can choose c to be equal to 0. So this is my integrating factor. Now we have initial value problem, but it doesn't matter as long as we know how to find the general solution. Finding the particular solution is just a matter of solving an algebraic equation for c. In this case, we recognize we have a linear first order differential equation, so we divide everything by -x, there's no more x over here. We identify this as p, this is my q, so we're going to find the integrating factor as e to the power integral of p dx. Now I'm going to find integral of p dx as integral of 5 cosine 5x dx, which is simple sine of 5x plus c, and we can choose c to go to 0. So my integrating factor is e to the power sine of 5x, and now I multiply everything by the integrating factor, so my left hand side becomes the integrating factor times y, all that the derivative of, and the right hand side simply because becomes the original q function times the integrating factor. And now to undo the derivative on the left hand side, we're going to take the integral, and the following substitution will give you the right answer. So if we just let t to be equal to 5x, we're going to be able to work it all out. So we have, actually not 5x, t should be equal to sine of 5x here. Then dt will be cosine of 5x times 5. So we're going to have 2e to the power sine of 5x plus c. And to isolate y, we're going to divide everything by e to the power sine of 5x. So it's going to be 2 plus c e to the power negative sine of 5x. And here I'm using the following property. 1 divided by e to the power a is same as e to the power negative a, in case if you wonder. Now let's type the answer. 2 plus c e to the power negative sine of 5x. That's interesting. I just realized that I forgot to solve this as an initial value problem, but I was marked correct anyway, which is lucky me. So let's not forget that we have an initial value problem, and that is that y of 0 is equal to 9, meaning we have to find c. So we're plugging in 0, 2 plus c e to the power negative sine of 0, all that will be equal to 9. That means c is equal to 7, so the particular solution that we were looking for is this. But I was marked correct anyway. But this is the correct answer anyway, so let's not feel bad about stealing an attempt from Newton. And to the next question. So this was question 15. Next question is 16. We have another initial value problem, and this time I'm not going to forget that it is an initial value problem. So the first step is to write it in standard form. So let's go ahead and divide everything by negative 8x. So we should assume that x is not equal to 0. So dividing everything by negative 8x will give me this. We have y prime plus 6 times 1 over x y equals to plus 4x plus 8. Now this is my p, this is my q. We're gonna find the integrating factor as e to the power integral of p dx. So it's going to be e to the power integral of 6 over x dx. So it's going to be e to the power 6 ln absolute value of x plus c. But we can assume that x is, I think it's pretty fair to assume that x is positive here. But regardless of whether x is positive, we just have e to the power ln of x to the 6. Now it doesn't matter if x is positive or negative, and the integrating factor is just x to the power 6. Now, after we multiply both sides by x to the power 6, on the left hand side we're going to get x to the power 6 times y. All that derivative, and on the right side we're going to have 4x plus 8 times x to the power 6. Now to find x to the power 6 times y, we're going to integrate. And on the right hand side I'm just going to distribute everything, which makes it a very easy integral. So we actually don't have integral anymore, it's just a polynomial. So we have 4 over 8x to the 8 plus 8 over 7 x to the power 7 plus c. Now we divide everything by x to the power 6, so we have 1/2 x squared plus 7x plus c x to the power negative 6. And now we're going to solve the initial value problem by plugging in 1. And c will be equal to 6 minus 7 minus 1/2. So I guess common denominator is 14. 14 times 6 is 84. Minus 16 minus 7. 84 minus 23 is 61. So 61 over 14. So the final answer is x squared over 2 plus 8x over 7 plus 61 over 14x to the power 6. And hopefully we didn't lose a sign or coefficient anywhere. So let's go ahead and check whether this is the right solution. It has to be right. Why wouldn't it be? So this was number 16. Next one is 17. Making slow but steady progress. So first we're going to divide everything by 10x squared minus 3. And in order for that to go smooth, I'm going to do some factoring here. And now you can see that after you divide everything by 10x squared minus 3, we simply have y prime plus x to the 5y equals to 3x to the power 5. And we have to make assumption that x squared is not equal to 3/10. And we're going to find the integrating factor. we can assume that c is equal to 0, so this is my integrating factor. Now we multiply both sides by the integrating factor, and we get, on the left side, we get the integrating factor times y, all that is derivative, and on the right side we have the original right side multiplied by this. Now to find this, we integrate the right hand side, and a simple substitution, t equals x to the 6 over 6, will do the trick. So the whole integral now becomes an integral of 3 e to the t dt. So it's 3 e to the t, but t is x to the 6 over 6 plus c. Now, isolating y by dividing both sides here and here by that e to the power x to the 6 over 6, we get y is equal to 3 plus c e to the power negative x to the 6 over 6. Now we're going to use the fact that y of 1 is equal to 5. And that means that c is equal to 2 e to the power 1 over 6, which means the final answer is 3 plus 2 e to the power 1 over 6 times e to that, but we can just use the properties of exponents and write it like this, which is a much nicer way of writing this particular solution. So the answer is 3 plus 2 e to the power 1 over 6 minus x to the power 6 over 6. Alright, that progress bar moving a little too slow for my liking, but the more practice the better. This was 17. Next one will be 18. And first step, integrating factor is e to the power integral of negative 3 cosine of 5x dx. So it's going to be e to the power negative 3/5 sine of 5x. Now, step 2, the integrating factor times y. I'm speeding up the process here, so skipping a few irrelevant lines. So integrating factor times y will be equal to the integral of the right hand side multiplied by the integrating factor. And this particular integral can be done with a substitution. The entire exponent can be replaced. So dt will be equal to negative 3 cosine of 5x dx. That means dx will be equal to 1 over negative 3 cosine of 5x dt. Now this integral becomes negative 6 cosine 5x e to the t, and instead of dx I'm going to write 1 over negative 3 cosine 5x dt. So this cancels. Negative 6 over negative 3 is just 2, so we have 2 e to the power t, but t is negative 3/5 sine 5x plus c. However, we need to isolate y, so we multiply, or rather divide both sides by this whole thing, which will be equivalent to this. And this was not an initial value problem, so this is my answer. Let's check. And that's correct. This was 18. I feel like we literally just did a problem like this, except this one is even easier. We have the integrating factor is e to the power integral of 2 cosine x dx, so it's just e to the power 2 sine x. Now the integrating factor times y will be equal to the integral of the right hand side multiplied by the integrating factor. Same substitution as in the previous problem will lead to the following answer. So it's going to be negative 3 e to the power 2 sine x plus c. Isolating y will result in the following expression. And again, it's not an initial value problem, so the general solution is what we are looking for. I don't know why it only moved 1%. So divide everything by 3x. We get y prime, of course, that's assuming that x is not equal to 0. We get y prime plus 8 over x times y equals negative 8x plus 9. The integrating factor will be e to the power integral of 8 over x dx, so it will be e to the power 8 ln x. C is 0, so it's going to be just x to the power 8. Now, on the left hand side, we have integrating factor times y, and on the right side, we have an integral of the right hand side times the integrating factor. Just speeding up the process here. So we get negative 8 over 10 x to the power 10 plus x to the power 9 plus c. And to isolate y, we divide both sides by x to the power 8. and we use the initial condition. To find C, and we finally write the answer. And let's plug it in. (21) We're going to divide everything by this leading coefficient. And in order for that to go smooth, I'm going to factor out some things here. So we're going to take out 9x to the 4 here. So we have 3 minus 2x cubed. I guess we can take out 3 over here too. So we get 3 minus 2x cubed. We have y, and on the right side we have what are we taking out here? 12? No. 9. 18. So we can take out 18x to the 4. So we have 3 minus 2x cubed. So if we divide everything by 3 minus 2x cubed times 3, so we have y prime. We're going to have to assume that 3 minus 2x cubed is not equal to 0. And we have y cubed plus 3x to the 4 y is equal to 6x to the 4. So this is my p, this is my q. First step, finding the integrating factor as e to the power integral of 3x to the 4 dx, which is equal to e to the power 3/5 x to the power 5. We can make c to be equal to 0. Step 2, on the left hand side we have the integrating factor times y. On the right side we have an integral of the original right hand side times the integrating factor, and this is a simple integral, and we're gonna substitute 3/5 x to the power 5 with t. dt will be equal to 3x to the 4 dx. So the whole integral now becomes integral of 2e to the power t dt, and the answer is 2e to the power 3/5 x to the power 5 plus c. The final answer is y is equal to 2 plus c e to the power negative 3/5 x to the power 5. Now we use, there's no initial condition to use, so we are done. So we have 2 plus c e to the power negative 3/5 x to the power 5. Number 22, we're going to factor out negative 10x to the 4 minus 5 from every coefficient. So here it's going to be 4x squared. So we have negative 10x to the 4 minus 5 times y, and here we have 16x squared so assuming that negative 10x to the power 4 minus 5 is not equal to 0, we obtain the following equation in standard form. The integrating factor is e to the power integral of 4x squared dx, so it is e to the power 4/3 x cubed. We can assume c is equal to 0 as always. Now the left hand side becomes the integrating factor times y. The right hand side becomes the integral of the right hand side times the integrating factor. We can do this substitution, and I can let you check my work yourself, but here's what we get. And this is usually when mistakes happen, when we skip steps, but let's see. So dt will be equal to 4x squared dx, and we have 4e to the t, so the answer will be 4e to the t plus c, so it's going to be 4e to the power 4/3 x cubed plus c. Now to isolate y, we divide both sides by the integrating factor. And now we're going to use the initial condition to find c. And the final answer, therefore, will be this. Why did I type y equals? So there's no equals here, just that. Well, hopefully this is correct, because All right, let's move on. We are only asked to find the integrating factor. So first let's write it in standard form. So let's divide everything by negative 5x squared. So we have y prime, so assuming that x is not equal to 0, we have y prime minus 2 secant squared 4x times y is equal to negative 2 cosine 4x. So the integrating factor will be e to the power integral negative 2 secant squared 4x dx, which is e to the power negative 1/2 tangent 4x, and we can omit the plus c. So here's the answer, e to the power negative 1/2 tangent 4x. So I guess the key here is not to forget to write the equation in standard form. Otherwise, you will be working with the wrong P and Q. So the integrating factor here will be e to the power integral of 3 sine 2x, which is negative 1/2 of cosine 2x. So let's go ahead and enter that. And just like that, we completed this homework. So hopefully now you know how to solve first order linear differential equations using the integrating factor technique. If you have any questions, please reach out.